just let me know when I can start.
Recording is on, you can start.
Okay, welcome to the next Easy Happy Hour. We are still in the topic series scaling software builds across architectures with automation. And last week we had a look more into goals and design decisions for the build bot we have. And today, so one wish at the end was that we today look into what really happens when we build, what happens in the background, what's going on, and so I hope I can show a bit of that. I will try to limit this at, let's say, maybe 15 minutes, or maybe if time is up, someone should just shout. And before I go, I was asked that I should just tell you about this new blog entry we have since last Friday. It's about EESSI on Kubernetes. So if you're interested in that, just have a look and you can find some information about that. So now going back to today's topic. And as you see, I have not prepared any slides. This was purely on purpose because I really just want to show how things look like. So the first thing I want to do is I show you how this looks like in, let's say, pull request. So we add all software to EESSI via pull requests. And so I thought that I do this via a closed one. And I think I was even picking this one here on top. So this was opened by someone who's not actually a maintainer of EESSI. And how this looks like is very simple. There's an EESSI stack file and just adding the name of one EESSI config file. There could be many more options, but very often also it looks like just that you add one single line and make a pull request to the EESSI software layer repository. And then by creating such a pull request, opening it, this and all kinds of other actions on GitHub, they create events, and the bot essentially acts on events. So one of these events is, for example, if someone creates a comment and writes something like this. So here in this case, Bob wrote a comment that the bot should build software, and it says for which SermWFS repository we want to build. So there's a kind of label for this. So that's for the new version in EESSI. It also states which instance of the bot should build this. So certain specific bot instances have access to certain CPU and GPU architectures. So if we want to build for Zen 2, I think we can use the bot on AWS, but also we could use the bot at Surf for this. And for example, if we want to build for A64FX, that's an ARM architecture, then we only have a choice to choose the bot that runs on the Kalian. That's one of the Euro HPC systems. So that's a command. But before we go into what happens there is to understand that when you register a bot or GitHub app, you basically tell GitHub where it should send these events to. So there I have no slides on this, or nothing to show. But essentially what happens is that then GitHub sends the event to that URL. And what is often used is a SME server, so SME.io. I can maybe go to this and just show you. I don't know if this actually exists there. So that's sort of a publicly available one. You can create a new channel, and that's basically gives you a URL, and then you can send events to that URL, or GitHub sends you events to that URL. But this you should only use for developing. We use not this public service, we use our own server for that. And then on the side where the bot runs, you run another component which is called, let me so it is called SME client. And the SME client connects to this SME server, for example, SME.io or our own one, and says here, I connect, please send me all events for this specific channel. And then whenever GitHub sends an event, it sends it to the server, and the server forwards it to this client. And the client runs, for example, on the build cluster we have. So that now we have already sort of this, and then sort of the event, they arrive at the site where the bot runs. Then the next thing is that at the site where the bot runs, and now I have to go to the EeESSI bot software layer. So this is the repository that contains the code for the bot. The bot uses something else. Sorry, I have more things to show. A small library developed by Kenneth. Yeah, go here and find. So that's a small library which basically creates a server and then can accept events which are forwarded from the SME client. And it checks, it validates the events. So there's some secret you have to create, or should create when you register a GitHub app. And this is used to validate these events. Otherwise, if you wouldn't do this, anyone who knows the channel ID could send you any event there, and then you wouldn't know if they actually originate from GitHub, for example. Yeah, so this is a central part of the bot. And once the event is validated, Peggy forwards this to the event handler. And so we have here basically two major components. That's the event handler and the job management. I think I will only talk about the event handler today. So you see here, there's a lot of configuration settings that we need, and the EeESSI software layer is inheriting from this Peggy module. And so what happens here is, so Peggy, maybe I go back to Peggy to show this. Okay, yeah, I think I checked this a little bit yesterday. So what this is doing, apart from initializing, so this has a handle event. So this is called, and then what it is doing, it is trying to figure out if there's a method that has this name, also this format of the name, handle underscore, then some event type, and underscore event. And if this is defined in the class that we define in the EeESSI bot, then it executes this method. Yeah, I think this is here. Yeah, and that's sort of the whole magic that happens there. And then we are basically in here. And then, for example, we have a method called handle underscore. Yeah, and in the end underscore event. So there's an event type here that is handled by this method is the issue command event. Yeah, and that's exactly the event that is generated, created, and sent to the bot when Bob created this comment with these commands. Yeah, so that's what's happening. So now we have to look into what is being done here, and there's a lot of stuff going on here. One thing maybe to note is it only acts on these comments if the comment was created. So if I would go back there and say maybe change, edit the comment, it would not react on this. That's maybe one thing to note. Then there's a little bit logic here to figure out if the comment actually contains a command for the bot or not. It could also be that you just write something, but it's not really containing any comment. Then an important next step is that we check permissions. So I think we have 3 types of permissions. We have command permission, so which GitHub account can send commands to the bot, which GitHub account can trigger builds like the one that Bob did there, and which accounts can trigger deployments. So these 3, I think, permissions we have. So first it checks if the account has this command permission. Let me go a bit. Then it creates, for all lines that contain a command, it creates a command and it reads the full line and checks all these arguments. And let me go a bit further. Then we have to be a bit careful how we process these comments in the pull request, because also the bot at the moment adds comments, and we have to want to avoid that we enter some endless loop, so that maybe someone adds a comment and then the bot creates a new comment and then would react on its own comments. Of course, we want to avoid that situation, and there's some logic here, like with that, and maybe also further on. And then we just process all these commands that we have passed from the comment, and there can be many. So if I go here to this pull request, in the beginning he just sent 2 build commands, but then later on probably sent a couple more. And here you see there's, I don't know, maybe 12 or so for the 12 remaining architectures. And all these are passed and then processed. And the processing is, let me check if I find this. Yeah, I think it's this one here, right? So I just have to look into this method, what this is doing. Let me just check. Yeah, so we take the command, check permissions. Yeah, I think. So then there can be different bot commands. Yeah, so that's also again using a similar logic with finding if there is a method with a specific name. Because we have different bot commands, we have build, we have status, we have help, maybe we have something else, maybe show config or so. So we have different commands, we have different then methods for these. Yeah, so for example, like help we have here, we have build, and so on. So and then of course build is the interesting one now. Okay, so what do we do with the build? So we do some checks if we actually had, if the bot command had some build arguments like the instance, repository, what do we want to build for, yeah, and if they are not there, let's say if the 4 is missing, then we just say, okay, sorry, we don't know what to build for. The next thing to check is if the account that created this comment actually has build permission. So this is checked here in this line. And then what we do is we call a function for submitting build jobs. Yeah, that's the next thing to look into. So that's in this module. So let's check. Yeah, so what we do is basically maybe three things here. We first prepare the jobs, and that means setting up the job directories. I think also fetching the pull request contents. Let me check if I go into this to just show you. Yeah, so there's always a lot of first maybe check getting some configurations and stuff, and then yeah. So here we create a directory for this job basically, and then we do something with accelerators and all stuff, and then yeah. Let me check. That is the next thing I want to show. Yes, no, that's not the one I wanted to show. I think here it is. So here in this line, we download the pull request, the content. And if you remember, in this pull request, there is only basically sort of, it's only the content of this repository. Yeah? So if you would go into Steven's repository here in this branch, you would see basically we download all this content first. Yeah. And there's not much in there. There's basically easy stack files. There's one script. We can also have a look into that later. Yeah, but there's really not much in there. Yeah. Then, okay, let me see if this. Yeah, we prepare some job config file that contains information about a job. All kinds of stuff we want to hand over to the build job later on. So then we return, let me think. Yeah, okay, so now we are back at this function here. Sorry, no, not what build. I have to go to what build. So we have submitted all the jobs. Yeah, sorry, no, I have to go back here. So first step was to create the job directories and download the content. That was this prepare jobs. If there were no jobs prepared, then we just return again. Yeah. So then the next step is we to submit a job, and then we create a comment in the pull request. And there's some more logic in there to just store metadata and so on. Maybe let's go into the submit job so that you also see what happens here. I think that's a little bit important. Let's see if I find it. So we get all kinds of parameters for submitting jobs. There are some general parameters for a Slurm job, but then also specific ones for the architecture. Let me see if I find what I want to show. Yes, so I think this one is important here. And so that's sort of the central job script that is executed. And I can show you how this looks like. Open a new tab. This is actually included in the bot. That's this one here, bot build. It's a configuration parameter, so you can also, if you run the bot on your site somewhere, you can also change this. But so this is the default job script. Does a lot of stuff, initialization, reading configuration. So it reads this job config file that we have created. So that's specific for the job. This has some interesting information like maybe the architecture, the installation directory, and so on. And then what this is doing, this now runs specific scripts in the that are provided by the target repository, so a software layer repository, for example. And what you see here is it would run bot/build, bot/check-build, and later it would run also bot/test and bot/check test. So if, for example, we would want to change what steps a job should run, we could add them here. Yeah. So now the thing is, we have to look a little bit into what this is doing. So where is it's not here. Yeah, so this is in Steven's repository. So here we only have the build, not the other. So you could ask, okay, where these other scripts come from. Maybe let's first have a quick look into this here. So this is a very short script, and the only thing it's doing, it's cloning the software layer scripts repository from EESSI, and then does some creates some symlinks to certain content scripts that are included, and then it runs another bot build script. Originally, what we had is that these two repositories, software layer scripts and software layer, they were one. And before all these bot/something scripts, they were all included in the software layer repository. But now they're in the software layer scripts. So that when you make a pull request, want to add some software, you don't see most of these scripts, and you don't have to worry, you don't have to change these scripts there, and it's also easier to maintain. So let me check. Yeah, I think I'm running out of time, right? So now basically, maybe instead of going too deep into what's being done here, I just go to this software layer script repository. So this repository now, assume you're already in the job running on the compute node, and this includes all the necessary scripts that are needed to build. Yeah? And what is initially called is this build script. Yeah? And then what happens is that it needs many of these. I don't want to say all, yeah, but the actual installation of software is in this EESSI install software script, but it also uses the EESSI container script to run everything in a container. It also runs the install software layer script, and that's a very small one, I think, yeah, so that doesn't do much. But then also it uses this run in compat layer env script. This we use to ensure that we run in the Gentoo prefix shell. Okay, I think in the interest of time, I will just stop here. So I didn't show everything. Maybe another session we could look into, let's say we are already in a job, what happens there? Maybe we can do this in another session. Then we can open for questions.
Does anyone have any questions on how we process all these contributions, all the automation behind it? It took us a while to get to this point, but I think in general, Thomas, we're quite happy with what we have right now, and it has proven to be quite robust. Or do you disagree?
Me? It was great. No, I think it's an iterative process. I think maybe the the interesting parts was to let's say we started from developing this very focused on building for software layer, easy software layer, but not really having in mind that we could, for example, also build for the compatibility layer. So if I go to easy compatibility layer, no, that's too many S's. Compatibility layer, yeah. So if I go here, you see a directory, also bot, and again it has sort of these familiar looking names of scripts, and that's those scripts. This is sort of an interface to the target repository. The bot doesn't have to know what exists, what it builds. And here we just define the interface, and then it can build anything. Yeah. Of course, and that figuring this out, this of course took some time. And if you look into specific scripts, I'm not sure. Maybe I go here. Yeah, I think if I go here, maybe over time we added support for other things. So if I look, for example, here for dev, I'm not sure if it's here. No, it's not here in this one. So we added support that you can also build for the development repository. And that, of course, we wanted to reuse what we already have and then edit this. And sometimes this can be a bit tricky to get it right, that it works for both, for the production repository, for the development repository, for the RISC-V repository. But yeah.
But all that logic is in this script repository, right? And
yes.
The bot is essentially clueless about what it's building for. It just follows the script and follows the whatever is added in the pull request where it's being triggered.
Yeah.
But yeah, it took us a while to get to this point, but I'm at least fairly happy with how it works now. And we also see the bot being used in other contexts, even outside of EESSI. So that does show that we have a pretty good design.
Yeah, so maybe another time I could look more into all the scripts that we are using. So let's say the bot/build script is run. What happens then? So that could also be interesting.
Yeah, and I think there we need something graphical, like a flow chart or whatever it is, because it's a whole maze of scripts and one calling the other. They each have their own purpose. So it may be good to untangle that a bit. Yeah, okay. Does anyone have any questions on this that they want to ask on the records before we close the recording? On this or on anything general in EESSI? If not, maybe Thomas, you can mention what will happen at the next happy hour before we wrap up the recording.
To be done. So next week, I think Davide can show a little bit of what he experimented with EESSI on Android.
Yeah.
Right? And yeah.
Yeah, we'll prepare a short demo on showing basically how we got to run server MFS on. Still need a rooted Android, and then sure we will be able to go around it, but still being able to run the EESSI demo on an emulated rooted phone.
Okay.
Yeah. Would it also make sense to have a Kubernetes one where you do a demo on how it works there, or is that difficult?
And do that. I mean, it's basically following the GitHub that I linked to at the end of the blog post, but I can do, if we have time, I can also try and do that.
I would say, Thomas, maybe that's a more interesting one for next time than the Android one. The Android one could be maybe the last one we do this year as a sort of fun, out of the box kind of final happy hour. Fine.
Yeah, we discussed that maybe the very last one we do this year is before Christmas on December 22nd, right?
Yeah,
Everyone who wears a Christmas hat can say the most important wish for EESSI for next year.
Well, that, and maybe we can even make it a small prize thing. If you wear a Christmas hat, you can win a coffee mug.
Okay, good.
Won't be able to do the demo on the 22nd because I will probably be celebrating my brother's birthday. So it's...
Well, then maybe next time we can do the Kubernetes and Android in one. I imagine the demo won't be taking.
Yeah, if I cut a little bit on the introduction, probably it should be fine.
Okay, up to you, Davide. No pressure.
Yeah.
Is it only the hat that wins, or we can wear sweaters?
No, you can be creative. If you want to go full Santa Claus, that's
Okay, I'm stopping the recording.
So just before stopping the recording, maybe to clarify, so we still have 2 sessions for this year?
Yeah.
So next Monday and the one after, yes.
Yes, 15 and 22, and then we'll skip 1 or 2. Well, at least 1.
Yeah.
I heard something about Kubernetes. Is there what do you mean by Kubernetes?
There's a blog post. I just linked it in the chat, Alain. So
okay.
The video has written, this one has written out how you can leverage EESSI in Kubernetes pods.
Okay, cool.
And the plan is to do a demo of that next week.
Okay, but I was asking, is there a document where there it is? So I'll take a look. Thank you.
We also had a question earlier from some attendees about this. I'm not sure, maybe it was Daniel, if you hear us, yeah? Does this cover your concerns, or you still request something more developed or more enhanced of what we already are presenting here and the next session's demo?
It's primarily in terms of the CVM FSESI driver that's we're interested in, but yeah.
Yeah, that's one of the things here. So maybe Davide can dive into that.
The demo will be mostly about that. The other were other things I explored before going to that and why it makes sense. But basically, when you run the CVMFS CSI plugin, it basically starts a daemon set that starts like 4 or 5 containers in 2 or 3 different pods, and when you make a request on a pods on that node, the container started by the daemon set of the driver will automatically load servimfs on your node, then it gets passed through to the pods. So basically, the nice thing about this is that you only the demo set and the plugin need to be started with admin privileges, but then all the pods using EESSI do not need to have admin privileges on your system. So if users can somehow start pods and it's not everything delegated by system admins, it's still better for security and also for I will show, but for managing the cluster itself, it centralizes everything to Kubernetes instead of having stuff split here and there.
Keep something hidden for next Monday. So
yeah,
we will run the
This is an
session.
interesting topic.
Yeah, so we'll run the session next Monday, and if there are anything still to be covered, we can still reach out for more advanced topics or see who can further help us in covering the questions. Yep. I will stop also the recording for now.